Yeah, so this particular testing mission is called as the Brinell Hardness Testing Mission. The purpose of this testing mission is to measure the hardness of a given material. So you can see that I will show you later on that there are two more missions which will also measure the hardness of the material. So previously we have seen the Young's modulus of the material, we have seen the shear modulus of the material, which are also material properties. Here we are going to measure using this particular mission another property of the material of the real solid bodies, that is the hardness. Okay, though it is very difficult to define what hardness is, intuitively it tells you that some materials are soft, some materials are very hard. For example, aluminum, you know very well that from our day-to-day experience that the aluminum material is softer than the steel. So similarly, so this is the basically a relative quantity, basically hardness. You will see that this particular hardness testing missions in the industry also, because the hardness, although it is not very precise material property like the Young's modulus and shear modulus of elasticity, but this relative measurement of the hardness of various materials can give us a picture of certain very important engineering parameters. For example, say in an industry a pipe is there which was, say for example, 25 years old, and you want to see that how healthy this particular pipe is or not. One of the parameter to see whether it is really can do some more service or not is to measure the hardness. Okay, so therefore from the values of that particular hardness of the material, one can decide that whether the pipe material has become weak or strong or still strong, many other advantages. So therefore, as you can see that these particular missions are also used extensively in the industry. Okay, hardness testing missions. So we have three types of hardness testing missions are there. One is the Brinell hardness, that is this particular mission. I will show you two more hardness testing missions, that is Rockwell, another is Vickers hardness test. Basically there is no difference between these three. It is only the scale on which we are measuring this particular property of the hardness is different actually. For some materials which are quite hard, and this Brinell hardness testing mission may not be able to take care of those materials. In such case, we have to take up another scale. For example, it is as simple as that. Say for example, if you buy a scale, okay, just 15 inches scale. So with the help of 15 inches scale, as you can see, you can measure only a few things. But if you want to measure, say, the dimensions of your house, that 15 inches scale is no more useful. So you have to depend on some other tapes and some other things. So in a very similar way, to measure the hardness of the materials, one mission may not be useful, and we have to shift to the other scales to find out the hardness of other materials. Some materials are extremely soft and some materials are extremely hard. For example, diamond is known to be the hardest material. Okay, basically if you see that hardness, basically people define that it's a resistance to the scratch. Okay, so if you try to scratch it, how easily you can actually scratch it. If you can do it very easily, we say that the material is less hard. But if it is taking a lot of struggle to scratch it, then we say that that particular material is very hard. But these are qualitative terms, and if you want to give some figures to this qualitative way of measuring, then the Brinell hardness testing mission is useful. Okay, so therefore what we do is that we put a small samples. Okay, so you can see that this sample size could be maybe hardly a 5 centimeters diameter, okay, or any piece. So you keep the specimen over here, and then you can see that by rotating this, see, you bring this into the contact, the top portion into the contact of the specimen, and then you apply the load. So you can see that all of these hardness testing missions have one typical feature. That is, as I told you, that we need to give, even if you take with the help of your hand, when you want to see something is hard or not, we normally press it with the help of fingers. So in a similar way, the hardness testing machines, instead of fingers, they use balls, basically steel balls, maybe the diamond shaped kind of a ball. I should not say ball, actually maybe kind of a ball. Then these balls try to press the material, and they try to measure how much amount of force that is required for pressing to an extent inside the material. Therefore, this Brinell hardness machine has a spherical steel ball, and then once you put the material specimen in between these two, and then if you bring the specimen in contact with the ball, then we apply the loads. Here you can see that here we apply the loads, and then the ball goes and then presses the material. So depending on the amount of ball pierces through the material, okay, from which we can find out a number, and that number is called the Brinell hardness number, okay, and that tells you the hardness of that particular material. So this is regarding the Brinell hardness testing machine. So let us move on to the other hardness testing machines, okay.
First we will switch on this hydraulic switch. This one, actually this machine is 3-phase current required for operating this machine. Hydraulic on. Now I will switch on this red light, red switch. Then light will on. Once light will on, we will choose which place on this surface we will focus. First we will, actually sample should be polished properly and shining surface should be there, otherwise if some dirt or rust is available there, then surface will not be clear. So I will put it in the center, and then we will rotate this lead screw or screw jack up to this mark. We will allow this sample to touch this clamp, touch this attachment. By rotating this, we will make it up, and once it touched, it is touched. Now this is your focus. You can see sample already polished, but small polishing marks are there, scratches are there. It is perfectly focused. If I bring it little bit down, then it will be unfocused. Now it is unfocused. Now this is focused and this is unfocused. This is focused. This focused. Then surface is focused. Now we'll go for indentation. For indentation, we need to use this lever. So first it is in read mode. Read mode means we can read it, see the surface to the objective piece. And now we will make it to unload. Unload means indentor is now positioned on the surface of the material, perfectly top of the material. Now once indentor is aligned properly, putting the indentor on the material, now we will go for load by pressing this lever. So some mechanisms are available, so that by using that mechanism hydraulically it will be loaded. So I will press this load once loading starts, this pressure goes, it will go on increasing, and at some point it will be stable. So from stable point we will count 15 to 16 seconds. This pointer rotates and at some point it becomes stable. From that point onwards we need to wait 15 to 16 seconds. After 15 to 16 second period we need to unload it by using this lever. I am going to unload, already unloaded. Now again we will bring it to read mode to object. Now this is the indentation. This is the indentation. This indentation diameter, x and y direction, we need to measure it. Whatever value x and y direction, this diameter, impression diameter we will get. From that two value we will measure, x and y direction. Both we will measure. After measuring, we will take the mean diameter, and that mean diameter value we will provide you at least 4 to 5 reading, and after that you need to put it that diagonal diameter value in your formula. Then you will, after putting that formula, you do the rest the calculation, then you will get the deviation number. So another 5 kg I am going to put. Now load this 10 kg plus this plate 15 kg, and another one more we will put. So now total 4 weights. So this 20 kg. This 20 kg and 20 kg hydraulically magnifies to, each one magnifies to 250 kg. 20 into 250 equal to how much? 1000 kg force. So 1000 kg force will be applied on this material. Still, that's why we will use higher load. And for aluminium, we have to decrease the load by looking, once we make the indentation and see the indentation size. Based on the size, we will change the load. There is a formula, Brinell hardness test formula. That formula is there, that whatever impression we will get, that is impression we will get, that is small d, and whatever the indentor diameter, that is capital D, capital D, and whatever the impression after the indentation, that is small d. So small d by capital D, this D ratio should be 0.3 to 0.5. If it violates, if it is not, that range is not within this value is not within this range, then we need to change the load, we need to alter the load. Either it is more than 0.5, then we will decrease the load, taking out the load from that load pan, and if it is less than 0.3, we will increase the load by putting the extra load pan available there. So we will accordingly we will go for testing. So this is micrometer. So here 3 scales are available. This least count is 0.01, then 0.1 and 1. So this, by using this micrometer screw gauge, we can measure this diameter of this impression. This is the manual, and this is the formula, and this is the descriptions. So whatever diameter you will get, that diameter values, indentor diameter and impression diameter, whatever value you will get, you need to put on this formula and do the rest of the calculation to get the BHN number. BHN means Brinell hardness number.
Explained that in the Brinell hardness we have 3 scales. Previously we have seen the Brinell hardness testing machine, from which the scale is called BHN. Okay, and another machine which will also measure the hardness of the engineering materials is the Vickers hardness testing machine. You can see this particular machine. The principle of operation between these two machines, all hardness machines, remains same. That is, you keep the specimen and take one either ball or some other shape of indentor, press it hard, and depending on the how much amount of force applied and how much that particular indentor has pierced through the that particular material, depending on that we can find out a number, and that number actually tells about the hardness of the material. Here in the previous case, in the Brinell hardness, the indentor is a spherical ball and which is made up of steel, but in Vickers the indentor is a square pyramid but they made of diamond material. Okay, so therefore you can see that very hard materials can be measured with the help of less amount of force on this particular scale. Okay, so otherwise the basic purpose of Brinell hardness and the Vickers hardness testing will remain same, except for the indentor, which has advantages of going for the higher hardness of the materials.
Hello everyone, I am Sanjeev Sharma, and this is Vickers hardness testing machine, and today we are going to show you how to measure Vickers hardness values of different engineering materials. This is the material, aluminum material, and this we will place it under this table, and this table height can be increased, means it can be, sample can be raised towards that objective piece. This is the objective piece of microscope, and it will focus the surface area where we will make the indentation. Hardness is actually resistance to stress or resistance to indentation of any material. So this aluminum material hardness value we will measure now by making some indentation. So this is our indentor. This is square pyramid diamond indentor. Tip is diamond. So by using this indentor, we will make some indent on the material surface. Now, for starting the experiment, we need to switch on we need to open this software. That is called Vickers software. We are going to open. For software opening, it is password protected. We will put the password, then software is open. Now we will change the load. This is the load changing knob. Generally for soft material we are using less load, means low load, and for higher strength material, high hardness material, we are using more load. So aluminium aluminum falls under soft material. We are choosing 10 kg force. So in this machine maximum we can choose 50 kg force, for making the indentation. So starting from 1 kg force, 5 kg force, 10 kg force, 20, 30 and 50 kg force. Now this is the software. So in this software there are different columns are available. So here according to the requirement we will put our different parameters we need to set here, and load also we need to, how much load, indentation load, that also we have to already choose, that also we have to put it here. So this is 10 kg force. I am putting here 10 kg force as selected knob is 10 kg force. So I am putting here 10 kg force. So after putting these things, then we will go for this one, done. Now we are going to focus the surface of this material. So this is a live screen. So we are going to bring this lead screw upward direction. Now surface will be focused. So we will focus in such a location so that there is no previous indent or nothing is there. So now we will focus it. We will focus the surface. So for measuring hardness values, generally material surface should be cleaned and it should be machined. Otherwise, lots of scratches, all these things are there. This is the surface. So here also some scratches are there, but still we can make indentation on this surface. This is the focus surface, and now we will bring this indentor in position. So bringing this indentor, this is the handle. Now we will bring this indentor in the position where we will make indent. This is diamond, that is diamond indentor, and that will indent. For indenting, we will, indentor is top of the surface of that material, and now we will press this button. Once this light goes off, then we will release this button, start button. Indentation process is going on. Indentation generally takes time, 15 to 18 seconds depending on material, and that timing can be set here in the material machine setting. So indentation already done. So now we will check by putting the objective piece. So this is the indentation. So this indentation is having two diagonals, as the indentor shape is square pyramid shape. Now we need to measure both diagonals length from this point to this point and this point to this point. Three methods: manual, semi-auto and auto. So better choose manual. We will choose manual. After choosing manual, now we will select the first diagonal point, starting point, this one, and then you bring it to the last point of that diagonal, in point. Then this is okay. If anything, if some this red line and this green line, if want to change, then you can change it by pressing reset, next, or done. So now we will go for next, then we will choose the diagonal of second diagonal by putting the first point here, then next point up to the end point. This is the diagonal. So now done. So once you done, this hardness values will come like this: 84.6 HB10. This means Vickers hardness value 10 kg force, and this is the hardness number at this load. So this is the test. This and the hardness diagonal values are like this. These are measured diagonal. 1 is equal to 0.4600 millimeter and 2 equal to 0.4761 millimeter. And mean diagonal, we need to, from this diagonal 1 and diagonal 2, we need to choose mean diagonal. From mean diagonal, value we should put in the Vickers hardness formula. There we will get the hardness number. That's all. This is hardness test manual. So we will provide you this manual soft copy, and as well as different materials hardness value we will not provide. We will provide you the diagonal values, and from those diagonal values you need to choose the mean diagonal values, and also we will provide the formula also along with that manual. From there you need to take the mean diagonal value and you need to calculate the hardness number. At least minimum 5 reading you will provide. You need to do the needful calculations. This is one table, and in this table you need to fill up all these columns. Materials to be tested, whatever material you have used, we will give you the materials name. Aluminum and steel generally we use, that you have to write here. Load, how much load we have choose. We have choose for aluminum we choose 10 kg force. For steel it may be higher, like 10 kg, 20 kg, 30 kg. And indentation D1 and D2, that is diagonal values. D1 and D2's value will provide. Mean diagonal you need to calculate, and then from mean diagonal you need to choose the variation number. Suppose for aluminum you choose 5 reading, then you will for each reading you will get numbers, individual variation numbers. From that 5 reading if you choose, then from that 5 reading you need to take the mean variation values for aluminum and steel. And there are some questions. These questions answers you need to be quiz. These questions answers you need to be right properly.
Another hardness testing mission which is known as Rockwell hardness testing mission. Therefore, we have 3 hardness testing missions. One is the Brinell hardness testing mission, second is Vickers hardness testing mission, and the third is Rockwell hardness testing mission. Therefore, you can see that again the function will remain same. We will keep the specimen between the two. One is in this particular space, where the top one contains the either ball or diamond pyramid or something indenter, and the bottom one is useful so that it slides, it goes up and down, so that the specimen will go and touch this particular indenter. So here also the indenter is a
diamond indenter,
diamond, yes. So this Rockwell hardness testing mission has both the indenters, that is steel indenter and then the diamond indenter also, depending on the hardness of the material. One of the major advantages is that of the Vickers and Rockwell is that they give the values immediately. Okay, you don't need to, of course, nowadays because of the electronics, even directly they give the hardness value. Okay, but the Brinell hardness, you have to go for certain amount of calculations finally to land up with the hardness using the Brinell hardness testing mission. Okay, this is the major chief advantage of this. So depending on the material, we choose the either Vickers or whether Rockwell or whether the Brinell hardness testing mission. Okay.
Good morning students, welcome to the Strength of Material Lab. Already we have learned Vickers and Brinell hardness testing. Now we will go for Rockwell hardness test. We will use steel or aluminum for measuring the hardness value by using the digital Rockwell hardness testing machine. So hardness, as you know, resistance to scratch or resistance to indentation. So we will make indent, and that indent will be measured in Rockwell hardness test machines. So this is a sophisticated instruments in the Rockwell hardness test. We can automatically get the hardness values in digital display. So we are going to use digital Rockwell hardness testing machine. This is the machine. In digital Rockwell hardness testing machines, according to the materials, we need to select loads and scales. These are the scales and load. What type of materials, applications and use, we need to choose the scales. So A scale, B scale, C scale, like the different scales are there, and according to the material, what material we are using for measuring hardness, we need to choose the indentor and scale. So this is a digital machine. So here today we will use one standard test block. So in my hand you have seen this standard test block. This standard test block will be used for measuring the hardness values. So now we will place this material here on this small table. This is screw jack, so automatically it can be raised up or down by pressing this up arrow and down arrow. So here we will put the material here. This is the indentor. This is called indentor. Tip is diamond tip. This tip is diamond tip. So now we will go for indentation. Already load we have already shows 150 kg force, and this is the scale selection knob. So as machine is automatic, digital automatic machine, so scales load only we need to choose manually. Rest of the things, scale and all these things, automatically we can choose here. So for these things we will go main display. So here set scale, already we have set the scale APPARATUS. APPARATUS means Rockwell hardness in C scale. So limit, so upper limit, lower limit. So this is some reference scale. Suppose one material's value known to us, suppose one material's value 60, then above 60 we can put some values as a upper limit, and below 60 some values we can put as a lower limit. And 5 seconds is dwell time, that means indentation time. So indentor will be pressed against the material for 5 seconds. So one more important thing is that this machine can be used for polymer, nylon and other composite materials, whereas Rockwell and Brinell hardness testing machine cannot be used for composite and other metallic materials. Here along with the metallic materials, polymer, nylon, other synthetic, composite, different other materials can also be used for measuring the hardness values. But at that point scale will be changed, indentor size will be changed, indentor will be changed. There are different types of indentors, ball indentor, diamond indentor. So load will vary, indentation load will vary. So everything will change according to the application, according to the material. So now as our material is metallic material, this is standard test block. So now we will go for measuring the hardness of this standard test block. So now auto mode on, that means if we press this, then automatically it will indent. So now we will go for these things. Here that results, whatever results you will get, that those things can also be printed. Automatic thermal printers are there, so automatically we will get results like this type of printed sheet. We will get hardness value will be where hardness value will be mentioned. So now we will do the actual test. So now I will press this arrow. Now as sample is placed, so sample we need to bring furthermore upward direction, near about to the closest to the this indentor tip. So for this we will need to press this upward button. If we press this upward button, then indentor, this table will moves up, as you have seen. Table will move up. We will bring some more closer. Now it is placed properly, material is placed against the indentor. Now we will press this button or either this button. If we press this button, then also cycle will start, or otherwise you touch this here, then also cycle will start. So here loading and unloading, preloading, loading, dual and unloading happens. After that hardness value will get 64.8. So this standard test blocks hardness value is 64.8. So accordingly you can choose different locations of this material and you can measure the Rockwell hardness of this material, and you can go for other engineering materials, metallic materials also. Suppose aluminum also you can use, or if you use aluminum for measuring the hardness, then indentor will be different. 1/16 inch ball you need to choose. So here I will show you these things. These are the scales. These are the scales. You have seen HRA, HRB, HRC. Total 3, 6, 9, 12, 15, 18, 21 scales are there in digital Rockwell hardness testing machine. Here we can put different place different indenters, materials. This is just box for keeping the indenters and other materials, and this is the full machine. So this is the automatic digital hardness Rockwell hardness testing machine. So by using this machine we can use the hardness, measure the hardness of different engineering materials, polymers, composites, etc. Thank you all. In Rockwell hardness testing machines there are different types of indentors, and according to the types of indentors there are different scales, and plastics, polymers, nylons and other engineering materials can also be tested here. We can measure the hardness of other engineering materials. So this is one table pasted side of that machine. So you can choose which type of indentor and what are the load we need to put for indentation. Based on that, pasted this table. So as you have seen in this table, so for different materials different load requires, and scales will be different, indentor size also will be different. So here mainly for metallic materials we generally use B scale or C scale. Sometimes some other scales also need to be used for other materials depending on the use and applications. So these things here it is clearly mentioned what type of materials that we are going to use for measuring hardness, and what are the load values, and what are the scale name, what is the scale name. Accordingly we can choose and we can go for measuring the hardness. So this is a digital machine. So this is a digital display, and here different buttons are there. This is start button, this is emergency stop, and this one that this specimen will go upward direction if we press this one, and if we press this one then specimen will go downward directions, material will go downward directions. And load selection knob is this one load selection knob. For C scale, suppose HRC, Rockwell hardness in C scale, that means if somebody says that HRC value is 73, that means we should understand that load value 150 kg force, indentor is diamond indentor, pyramid cone shape diamond indentor, and scale is C. So that is the meaning of HRC 70. That means in C scale this is the hardness value. So this is another knob. This knob is used for selecting the scale, which scale we will use. This is one of our standard specimen, standard test block. So first we will use this block for measuring the hardness value of this block. So first we will place this block here. So I will put this block here. Then we will select the scale. Scale for selecting scale. This is the, we will select scale. HRC already it is selected. Now for some reference scale we need to put some values, 99.9, 35.5. These are arbitrary values we can choose. Suppose one material hardness known to us like for example this material hardness, this is standard test block. We know hardness value of this material. This material is supplied along with this machine. This is standard test block. So this material hardness value around 60.5. So whether after testing whether we will get 60.5 or 6, that we will check. After that we will go for our material mild steel. So before starting you need to set the sample material we need to choose. We need to place it on this screw jack table. So after putting, we need to press this button so that specimen will goes up. Specimen will goes up near the indentor. So before that, once again we will check the material. Material should be polished. Here already it is polished, but small scratches are there. But some scratches also there, then we can use in Rockwell hardness. But if more scratches are there, that cannot be used for measuring the hardness. So now we will choose one location and then we will press this. We will press this. Now we will start the indentation. For starting the indentation, we need to press this green button and then we need to press this one. Press start. So now we are using aluminum. We will measure the hardness of this aluminum by using the digital Rockwell hardness testing machine. Hardness value will be automatically displayed in the display. So we will use this material, and according to the materials we will use the scale 1/16" ball and 100 kg load for aluminum and aluminum alloys, copper alloys. So as this material is aluminum, we will choose the indentor 1/16" ball, and now we will also change the load. So for changing load, we need to rotate this knob. This is 60, now this is 100. This 100 kg force load will be applied. So now scale also we will choose. So for scale choosing, this one already it is in C scale. Now we will make it to B scale. So this is D scale, this is B scale. Now press enter. Here generally for aluminum hardness value, generally in B scale in Rockwell hardness, it comes generally 45 to 35. So that's why some references of H means some higher values of that, and that we will set here. For setting that purpose, we will put it 45, press enter, then again we will choose some lower values 30. That is nothing with that hardness values, just for reference some higher values and some lower values of that material. This is for just for reference purpose. Now press enter. Now it is time. Time means dual time. Dual time is that indentation time. So that will be 5 seconds. So now we will press here. Now what we will do? This is screw jack. So this jack will be rotated clockwise direction, and then we will press this material against the indentor. So I am choosing one good location where no earlier indentations. Already some indentations are there, some Brinell hardness testing machines indentors indentation, and some are Rockwell's earlier indentations. So now we will put this surface. So this surface we will choose some good locations where no earlier indentations are available. So I will put this material here and I will press this against the indenter, so that this I will keep on rotating, so that this light will, red light will come and it will show here green up to the set point. That means this is all minor loading, so that some scratches or some roughness or some layer may be there, some rustings may be there on that material, so that if we keep on up to set value, if we put it, then that means indenter will be penetrating that layer, and when we do the actual hardness measurement, then it will touch the original material, so that we will get the original material's hardness value. So for that purpose we need to press it up to set. Now again we will start this green, press the green button, to getting the value of hardness. So now I am pressing here, this button I am pressing. Once this light glows while pressing, once this light glows, then we will release the press, and now hardness value will be coming like this, 28.8. So this is, again we will use this surface. So I will again do the same process, put the specimen where we will make the indentation, put the specimen and then press it, so that this will come to set. Once it is come to set, now you press this button till this light not switch on. I am pressing it. Once it switch on, I will release this. I am pressing it. Now I am releasing. Now indentation process is going on. So you will finally get the hardness values. This is 30.3. Generally for aluminum, different grade aluminiums, hardness values are different. For this aluminum, commercial aluminum, this hardness value generally ranges from 28, 29 to 40 in digital hardness reading. So this way we need to take 5-6 readings, and accordingly you need to put it in your report, these values. So here calculations like Brinell and Vickers, you need to do your own calculations, but here you no need to do these calculations. Automatically these values will appear here in digital Vickers hardness testing machine.